Welcome back to Advanced Skills Learning. GenAI prototypes are easy. Production systems are hard. In this series, we focus on the decisions that determine whether your system actually works at scale. Here's a hard truth about RAG systems. Your retrieval is only as good as your query. And most user queries are terrible. Users ask vague, incomplete, or ambiguous questions. They skip context. They use shorthand. They assume the system understands intent. But your retriever doesn't understand intent. It matches text. So what happens? Bad query goes in, irrelevant documents come out, and the LLM confidently generates the wrong answer. And this mismatch happens because users optimize for convenience, not for retrieval systems. This is why many RAG systems fail silently. Nothing crashes, nothing throws an error, but the answers feel slightly off, inconsistent, or incomplete. And the root cause is subtle. The query does not match the user's actual intent, and retrieval operates purely on that mismatch. This makes the problem harder to detect because the system appears functional while quality slowly degrades. This is where query rewriting becomes critical. Query rewriting is the process of transforming the user's input before retrieval. You take a messy, human query and turn it into something structured, explicit, and searchable. Think of it as translating from human language to retrieval language. Often, this step is powered by an LLM, but it can also be rule-based or hybrid depending on your system. The goal is not to change the meaning, but to make the intent machine readable for retrieval systems. Let's look at a simple example. A user asks, "Why is it slow?" That's useless for retrieval. A rewritten query might be, "Why is RAG latency high in the retrieval stage due to vector search or reranking?" Now the retriever has something meaningful to work with. This is the difference between guessing and targeting. The rewritten query introduces structure and intent, which directly improves how documents are matched. There are three main types of query rewriting. First, clarification, adding missing context to make the query explicit. Second, expansion, adding related terms, synonyms, and domain-specific keywords. And third, decomposition, breaking a complex query into multiple smaller queries. In practice, production systems often combine all three techniques depending on query complexity. Expansion is especially powerful. If a user says vector search issue, the system can expand it to include terms like embedding similarity, and search, and retrieval latency. This dramatically improves recall and helps surface the right documents. This is especially important in domains where terminology varies widely across documents. Decomposition is useful for complex questions. Instead of forcing one query to do everything, you split it into parts. Retrieve results separately, then combine them. This is how you handle multi-step reasoning in RAG systems without overloading retrieval. This approach reduces retrieval confusion by isolating each part of the user's intent. Architecturally, query rewriting sits right before retrieval. The flow becomes user to rewrite to retriever to reranker to LLM. And this small addition can change everything. Even a lightweight rewrite layer can significantly improve retrieval without changing your core infrastructure. Here's a quick check, 2 seconds. What's the main goal of query rewriting? A. Reduce token cost. B. Improve retrieval quality. C. Speed up the LLM. Keep your guess. The answer is B. This is why improving the query often has a larger impact than tuning the retriever itself. Now here's why this is called a multiplier. Because it improves every downstream step. Better queries lead to better retrieval. Better retrieval leads to better reranking. Better context leads to better answers. You're not fixing one component. You're amplifying the entire system. It acts as a force multiplier because every downstream component depends on the quality of retrieved context. But like everything in production systems, there are trade-offs. Query rewriting adds latency, especially if you use an LLM. It can also overexpand and introduce noise if not tuned properly. And domain matters. A rewriting strategy that works for legal documents may fail completely in e-commerce or healthcare. So this layer needs careful design and evaluation. That's why many systems use selective rewriting only when queries are ambiguous or complex. Here's another quick check, 2 seconds. Which rewriting type breaks a query into parts? A. Expansion. B. Decomposition. C. Filtering. Keep your guess. The answer is B. Decomposition is particularly useful when a single query contains multiple hidden questions. So here are the key takeaways. In RAG systems, query quality directly determines retrieval quality. Query rewriting aligns the query with user intent. and a small change at the input can create a massive improvement across the system. If your RAG answers feel off, don't just tune your vector database. Look at your queries, because sometimes the biggest improvement comes before retrieval even begins. If you improve the input to retrieval, you improve the entire RAG pipeline end to end. Thanks for watching. If this video helped, like the video and subscribe to Advanced Skills Learning for more GenAI explainers, practical architectures, and quick quizzes to test your understanding.